I'm going to work out some oxidation number problems, and I know that some of you have been having some concerns and some questions about how to solve or predict the oxidation numbers within a compound. And again, when you're thinking about how to determine the oxidation number, it's nice to know your 10 polyatomics. It's nice to know your 52 elements, names and symbols. It's nice to know what the most common charge on elements are, and et cetera, et cetera. So all the things that we've been learning and talking about in the past up to this point in the year, you want to be strong at that. So go to the website, click on schedule, honors chemistry, second semester. Right now it's January, and I believe it's going to be the more redox oxidation numbers questions. So we'll pick on that, and we're not going to work out the redox, that's a different topic, but we'll come down, or we'll look down here to these questions here. Let me blow this up just a little bit so it makes it a little more interesting and we can work on those. Okay, so here's what we're going to work on, these examples here. All right, so looking at the first one, again, one of the best strategies for working out a problem like this is to treat each of these and doing somewhat of an inventory. So I have my tungsten, I have my phosphorus, and I have my oxygen. Actually, let me move that all over here. So I have my tungsten, I have my phosphorus, and I have my oxygen. Okay. I want to find out how many of each I have. So I have 3 tungstens, I have 5 phosphorus, and I have 20 oxygen. Okay. And my goal is to find the potential charge or the oxidation number for each of these elements based on what's on the periodic table. So when I go to the periodic table, and I've blown this up a little bit, the periodic table has your elements with all of these different oxidation numbers. And again, these are the potential charges that those elements may have when they're with another compound or another element. So when you look at something like nitrogen, it can either be +1, -1, +2, -2, +3, -3, +4, +5. So there's a lot of potential different charges there. But when we look at oxygen, oxygen's pretty nice because it's only a +2 charge. So since we know that oxygen's only a +2 charge, when we go and determine its oxidation number, it makes it very easy. It's a -2. So here's what we want to do. Once we know what the oxidation number for one of these happens to be, then we're going to actually multiply the oxidation number by how many we have. So in that case, that gives me a total of -2 times -20 is a -40 charge. Now keep in mind, all of these elements with their charges, when I have all the full charges here, this whole thing will equal 0 because again, we always want to make sure that we balance this out so that the metal plus the non-metal equals 0. So we're always going to balance those charges. Okay, so we know the charge on the oxygen. Now when we look at phosphorus and tungsten, those are really tricky because phosphorus can either be a +3, -3, or +5. We're not going to say it's a -3 because it's not the only non-metal. If this were the only non-metal and say that we had, say, tungsten and phosphorus, then phosphorus is going to be a -3 charge. But if it's with another non-metal, in other words, it's forming this polyatomic, it's very doubtful that it's going to have a -3 charge. It's not unlikely, but it's very doubtful that it will. So what I need to do is, I need to find out what the charge on my metal is to help me find out what the charge on the non-metal phosphorus is. So again, this is one of our 10 polyatomics, phosphate. So I'm going to hone in on the non-metal. I'm going to let the non-metal tell me what the charge on the metal is. So I know that I have a phosphate here. What's the charge on each phosphate? That's right, it's a -3. How many phosphates do I have in this compound? And again, when I say phosphate, phosphate is PO4 with a -3 charge. Phosphide, which I don't have in this compound, would be the W with the P. And I don't just have a P by itself. So if it ends in IDE, then you're looking at just simply one non-metal. But we don't have that. We actually have phosphate that ends in ATE. Okay, big difference. So make sure that you're saying that to yourself. So again, we have a -3, we have 5 of those, and again, this whole thing should equal 0. So all the nonmetals, all my phosphates, contribute a negative 15 charge. So that means all my metals, which in this case is tungsten, will have to exhibit a plus 15 charge. Well, if it has a plus 15 and I have 3 of these tungstens, what must the charge on each tungsten be? Correct, it has to be a plus 5 charge. So what that means is each tungsten has a plus 5 charge. We want to check it and validate it. So we'll come over here, go to your periodic table. And tungsten can either be plus 6, plus 5, plus 4. Well, we don't need to go any further. We do have a plus 5, so that is a good value. So we have a good number, and that's what you want to be doing, looking at your periodic table. Is it a legal number? If not, you need to go back and check your math. So in this case here, I have 3 times plus 5, which equals a positive 15. Okay? So now I have the full charge of my tungsten. My oxidation number is 5, but I have 3 of those, so it has a full charge of 15, positive 15. Oxygen has an oxidation number of negative 2. I have 20 of those for a full charge of negative 40. So now I need to find out what number here, when added to positive 15 and negative 40, will give me 0. So I have to do that mental math in my head, which I know some of you love to do. So correct, it should be a plus 25 charge. So all the phosphorus are going to exhibit a plus 25 charge. Well, if they have a plus 25 and I have 5 of those, what must the charge on each phosphorus be? Correct, plus 5. Before you go any further, check and make sure that's a legal charge. So we come over to the periodic table, and phosphorus can either be plus or minus 3 or plus 5. It's a good number. So when we look at our oxidation numbers are these in the box. So tungsten has a plus 5 oxidation, phosphorus has a plus 5, and each oxygen has a minus 2. Now what I don't want you to do is say, well, wait a minute, plus 5 minus 2, that doesn't equal 0. Correct. It's all of these times the total number of atoms that we have that equals 0. Okay? Let's look at the next one. And again, try working these out before you listen to me explain this. That'll probably be more beneficial. So here we go. So let's write out what we know. We have 1 zinc. We have 1 carbon. We have 3 oxygen. Okay. And again, you should know just by doing it numerous times that the charge on oxygen will always be negative 2. So you should get to the point right now that as many times as we've used oxygen, it should be automatic. And I'm not trying to be mean when I say that, but seriously, you've got to start recognizing certain things or certain charges. Okay, and all of this will equal 0 because there's no charge given here. Again, use your non-metal to help you tell what the charge on your metal is. So in this case, we have carbonate, which is our non-metal. What's the charge on carbonate? Very good, it's a negative 2. How many total carbonates do we have in this compound? Correct, we don't have a parentheses, so that means we just have 1 of those. So how many zincs do we have? That is correct, we also have 1 of those, and zinc has to be a plus 2 charge. When you go to the periodic table, there's zinc, and it only has a plus 2 charge, which is very nice. So you know that zinc is a plus 2. So plus 2 times 1 gives me that. And now we want to find out what is this missing charge here. And notice what I'm doing. I'm finding the oxygen, finding the metal, by using the non-metal to help me tell what the charge on the metal is. So now that I have that, so I know that if this is going to equal 0, I need to have a plus 4 charge here, which means that carbon should have a plus 4 charge as well. And it does. It can either be a plus 4, minus 4, or a plus 2. So my oxidation numbers here are that. So zinc has a plus 2, each carbon has a plus 4, each oxygen a minus 2. It's a lot easier, isn't it? Let's look at the next one. Okay. Here we have titanium and then we have iodate, but 3 of those iodates. So again, don't freak out, just write them out. So we have titanium, so Ti, and we have 1 of those, right? There's no subscript, so we have 1 titanium. Iodine, how many iodines do we have? Correct, we have 3. Oxygen, we have a total of 9. Very good. Not 6, but we have 9. Again, oxygen has a -2 charge. Very good. And every single one of these problems, the total charge will be 0. So I know that 9 times -2 is a -18. Okay. So looking at titanium, which is here. Titanium can either be a +4, a +2, or a +3. And don't freak out and go, why are those not in order? Don't worry about it. So it can be either +4, +2, or +3. So we're going to figure out what that charge is. So here again, identify your non-metal. Let your non-metal tell you what the charge on your metal is. So IO3 is your non-metal, 1 of your 10 polys. And unfortunately, that polyatomic is not on your double replacement sheet. So you have to know your 10 polys, okay? So iodate has a -1 charge. And how many do we have? That's right, we have 3 of those. How many titaniums do we have? Correct, we only have 1 of those. So the charge on that titanium must be a +3. So when we look at that, we have a +3. And double check, make sure. Yes, it does have a +3 charge, and don't worry that it's not bold. As long as it's one of those legal numbers, we're happy. Okay, so now that we have that, now we need to find out, okay, well, what number, when added to +3 and -18, equals 0? So in this case here, we know that we need a +15 charge overall for all the iodines, and therefore that would mean that iodine has a +5 charge. Before you walk away, make sure you check to see that iodine can have a +5 charge. So we scroll on over iodine. There's iodine. It can either be a +1, -1, +5, or +7. And there's our +5. Okay. So again, titanium has a +3, iodine +5, oxygen -2. All right. Let's look at number 4. Okay, so we have our iridium. And we have how many iridiums? Correct, we have 1 of those. We have, this is chlorine and 3 oxygens. That's not an I. Your I would look like that. These are 2 very different things, so don't freak out and go, oh, is that a carbon, iodine? No, it's not. It's an L. That's an I. So make sure you can distinguish between the 2. So we have chlorine. And how many chlorines do we have here? Correct. We have 4 of those. And oxygen, we have a total of 3 times 4, 12. Okay. So again, oxygen's -2. 12 times -2 is -24. That equals 0. Now here's another trick. This is kind of neat. If you look at the subscript for iridium, what subscript does iridium have? It doesn't have one, but really it has a 1 there, okay? Also, you notice that there's a subscript 4 here. I talked to you about this earlier, that if we switch places, okay? In other words, if I say, all right, well, I have a 4 here, so that means that this has a +4 charge. Looks good. This has a -1 charge. That's a really good piece of information to use. It's very, very beneficial. In other words, if you look at the others, okay, like titanium we said had a +3 charge, and the iodate had a -1. Ooh, that's really nice. So if you use that information, it can really speed things up. So knowing that the chlorate has a -1 charge and the iridium has a +4 charge, that can help speed things up. Now, if you're not happy with that, then you can still go and say, okay, well, what's the charge on chlorate? ClO3, 1 of your 10 polyatomics. Each one of those has a -1. You have 4 of those. And so the total is equal to 0. And I have 1 iridium, which does have a +4 charge. So that means that we have a +4. So there's our charges. Now this one's a little interesting because again, we have chlorine and we have 4 of those. So what number here, when added to the -24 and the +4, will give me 0? Correct, it'll be +20. So 20 divided by 4 is a +5. Now again, be sure you check to make sure that chlorine can have a +5 charge. And chlorine, where are you? Up a little higher. So chlorine can be +1, -1, +3, +5, +7. Awesome. Okay. So again, I'm hoping this is getting a little easier for you, but this trick is really nice. Okay. And if you go back in the video and look at that, you can go, oh yeah, we can definitely make this a lot easier here. Now, this is one of the exceptions. If you look at the zinc carbonate, and you're saying to yourself, well, I have one of those. Technically, I have one of those and one of those. Well, what's happened here is that it's been reduced down to the simplest whole number. This isn't a +1 and that's not a -1. These are actually -2, +2. And we wouldn't show a 2 and a 2 here. That would be bad to have a 2 and a 2 because again, that can be reduced. So we always simplify this down to the smallest whole number. So if you have numbers, always double check and make sure that the charges are legal for that. Here, this works great. We know that our tungsten had a +5 charge and our phosphate had a -3 charge. Okay, our phosphate, PO4 with a -3, has a -3 charge. So again, that's something that you can use to quickly check. But again, as I stated in our zinc carbonate here, you gotta look on the periodic table, unless you just have that periodic table memorized, and I don't care to, unless you just use it so much. All right, so let's look at the last one, where we have Bi2SO4, and there's a 3 there. And I can see where you're going. You're sitting here thinking already, all right, there's a 2 there, so this has a -2 charge, and you know sulfate has a -2 charge, which is good. And then you can say to yourself, well, bismuth has a +3 charge. Well, check and see. Bismuth is down here, down by lead. So where are you? Bismuth, where are you? I passed you? Oh, here we go. Can either be a 3 or 5 charge. So that right there is telling you that we're looking at some good information. But again, go through your process. Unless the question just asks, what is the oxidation number for bismuth, then you got it. Okay. So we've got our bismuth. We have 2 of those. We have our sulfur, and we have 3 of those. We have our oxygen, and we have 12 of those. So again, you know that each oxygen is -2, so -2 times 12 is -24. There's 0. The bismuth, again, here, let me clean this up. We know that each sulfate has a -2 charge, and we have 3 of those. We have 2 bismuth, so it has to be a +3, which we stated just a moment ago. So that's a total charge of +6. So what numbers here, when added, or what number here when added to these 2, will give me 0. Very good. So we have it +18. So +18 +6 is equal to +24, -24, 0. So this means that sulfur will have a +6 charge. And of course, you always want to check sulfur, scoot it over, 6, sulfur -2, +4, +6. Awesome. Okay. So again, when working these out, oftentimes I'll never grade this type of work here. So there are shortcuts. You can use your subscripts to help you tell what the charge on the actual element is if you know how to use those subscripts.